Complex number review. This is section 2.4, pages 8 to 10. Please remember that I is equal to the square root of -1. It is not real. That's why it's called complex. I squared equals -1. We have the wheel of I. The wheel of I consists of 1, I, -1, -I, 1, I, -1, -I, 1, I, -1, -I, 1, I, -1, I. The pattern is whenever you have I to a multiple of 4, you always get 1. I is to an even number like 2, 6, and 10, but it's not a multiple of 4, and you end up with -1. You have odd numbers. Well, when the odd number is one more than a multiple of 4, you get I, so I to the 5th, I to the 21, I to the 25. These would be things that are one more than a multiple of 4, and you get I. You always get -I when you're one less than a multiple of 4. I to the 3rd's one less. I to the 59's one less. I to the 91 is one less. And so it's -I. So some examples. I look at 34. It's even but not a multiple of 4. 60's even and a multiple of 4. 88's even and a multiple of 4. 78's even and not a multiple of 4. 35 and 97 are odd. 35 is one less than a multiple of 4. 97 is one more than a multiple of 4. 59 and 41 are odd. 59 is one less than a multiple of 4. 41 is one more than a multiple of 4. Folks, it's this stinking easy. Now, when multiplying complex numbers, we must remember that the minute we get an I squared, we need to rename it. So first, just reviewing simple monomial multiplication. When I multiply this and then I put it in standard form, I rewrote it. Now what happens when I have i's? I squared is not a variable. I squared is -1. And I rewrite this. And I have to put it in a plus bi form, which is complex form, as -1 plus 2i. Remember, -1 plus 2i is really -1 plus 2 times the square root of -1. And when we have binomials, what do? We go ahead and distribute, and then we usually rewrite it in standard form. Well, what happens when you have I, guys? You go ahead and distribute, but what does I squared equal? -1. So -6i squared becomes +6. You rewrite it, making sure that the a, that is the real part, is always first, and the bi part is second. Now, remember, make a note of this, that the I is really a square root. It is a radical, albeit it's not a real radical, but it's a radical. So when I is in the denominator of your fraction and you can't reduce it, you must rationalize using the rules you did with real numbers. So reviewing, I see a square root 5. I'm going to multiply by square root 5 over square root 5. I get this answer. I simplify. Standard form is always to put the radical second, so I rewrite it as 10 plus root 5. So over here, I'm just going to multiply by I, top and bottom. What does my I squared equal? -1, so I get a -10. I then divide, but I have to put it in standard form, which is 10 minus 5i. And we'll do another example of that. So in this one, I could have divided those all by 2 first and said 2 plus 3i over I. I didn't, but I could have. And now I have I over I. But what do I end up with? Well, 6i squared is -6. 2i squared is -2. I divide, and then I have to put it in a plus bi form, which is standard form. Now let's remember, when you multiply complex numbers, you don't end up with a difference of squares in the end, but you actually end up with a sum of squares instead. So observe. you get, normally you wouldn't do this step. You would go straight from here to say 4 minus 9i squared. You're thinking it's a difference, but I squared makes it a positive, and it actually makes it something where I can go ahead and add it and call it 13. So generally, what happens when you see a plus bi and a minus bi? Instead of a squared minus b squared when the i's weren't there, you end up with a squared plus b squared. So now what happens when you have a radical expression, a complex number, where both a and b are present? You're going to rationalize it like you would a binomial denominator. Now I put root x's here. I could have put numbers here like 2 root 3 and 3 root 3. It doesn't much matter. I used x just to keep it a little cleaner. What did we learn to do? We write the difference of squares for the denominator. We distribute the numerator. We rewrite. You might want to put the 6x first and the 5 last. Nobody cares, really. What happens when I see a complex number? I do the same thing. But now, if you have it down pat, you know that this is not 1 minus 4. You know it's 1 plus 4. So it's 5. And you distribute on top. Do as much as you want in your head. But what is 6i squared? It's really negative 6. So combining terms, I have negative 1 plus 13i. But no, I can't leave it this way because standard form is an a, b, and an I. So I must separate. So I have negative 1/5 is my a, plus 13/5 is my b, and I have my I. I don't care if your Algebra 2 book didn't do it. You have to do it. Here's another example. So I have 3 plus 6i. The conjugate's 3 minus 6i. And so I'm going to have 9 minus, no, plus 36. And I get 45. So on top, I go ahead and distribute, and 66 is, I squared is negative 66. Combining my terms, and notice I have to separate them. I can't leave it like this. I separated. 15 goes into the first set and 45 into the second one. And I end up with negative 4/3 for my A, negative 1 for my B, and I. Now we can solve these when they won't factor over the complex numbers. Now earlier in the last section we had things like x squared equals negative 4. If I'd allowed complex numbers, you could have just said plus or minus 2i. But here I'm just doing the ones where we actually have to do the quadratic formula. So I found my a, b, and c. I found my negative b and my 2a, because I know the quadratic formula is negative b plus or minus the square root of the quantity, b squared minus 4ac, all over 2a. So I found my b squared minus 4ac. I found my square root, and I plug in my negative b plus or minus my square root all over my 2a, and I simplify to get 4 plus or minus 3i. We're going to repeat the process. So I need my negative b, my 2a. I need b squared minus 4ac so I can find my square root. So negative b is negative 10 plus or minus the square root is 6i. All over 2a, which is 2, and my final answer is negative 5 plus or minus 3i.